Good morning, everybody. Welcome back to lecture number 12. Today we will finish the material of major 1. Superposition principle. It's only applied for linear system. In electrical engineering, linear systems are systems that consist of voltage source, current source, and resistors. If you see a capacitor or inductor, those are not linear. You cannot apply superposition for non-linear systems, okay? What is the principle? The total response, either current or voltage, like for example IT, VT, is the sum of the response for the same quantity by having one source at a time. In other words, this problem, we should split it into two problems. Problem 1, it should be with the voltage source only. So how to kill the current source? Open circuit. So that is problem 1. So problem 1, it should be the resistor and the voltage source. Problem 2, you kill the voltage source and you keep the current source. How does it look like, problem 2? Current source and then a resistor in parallel with another resistor. Now the quantity that you're calculating is IT, so you can call it IT1, IT2. If you calculate this current and you calculate this current, IT in the original circuit is IT1 plus IT2. Get it? IT2 is going to be a number 0.5. IT1 it can be 0.7. But that IT is the summation of them, which is 1.2. In other words, if you want to use superposition, you have to keep one either voltage source or current source at a time and redraw the circuit. Solve the problem. Redraw the circuit for the other voltage or current source. Solve the problem. At the end, sum the answers. اجمع الإجابات. Is the superposition conceptually clear? It's very similar to superposition in math, where you have to equate one equation to 0, solve it, equate one equation to 0 and solve it, something like that. To simplify a 4 equations for variable, you can eliminate one, solve the system, eliminate the other, solve the system, and then sum the result, something like that. Now, how to apply it is through an example. In the first example, what did I tell you? The current source, it has to be killed. Once it's killed, we have a circuit of 15 volts. So what is IT1? So we have here, what's the voltage source? 15 volts. Resistor 1, 10 ohm. Resistor 2, 5 ohm. Plus, minus. So what is IT1? It's very simple. Quiz 1. 15 over 10 plus 5. What's the answer?
1.
1?
Yes.
1 amp. He is asking for the voltage drop across R2 in the original problem, which is VT. So let's also calculate VT1. So we call this VT1. 1 meaning problem 1. The same quantity is VT2 and IT2 is moving here. So how do you put the polarity? We're professionals. Plus minus, because we want the current to enter from the positive. The voltage here is VT2. So it is clear the voltage, or what is IT2? Well, you use the current divider. So IT2 is R2, this is is R1, which is 10, 5. Keep in mind that this current, IT2 negative, it's negative of IT2. So IT2 is going from bottom to top, so you really need to add another negative. Not a passive sign convention, it's just IT2 is moving from bottom to top. The CDR rule applied for the current that's getting splitted. This negative is not from the passive sign convention. If you reverse the signs of the resistor, then it will be the negative from the passive sign configuration. Right now, we put a negative because it's simply opposite direction. IT2 is from bottom to top. The current that is splitting is from top to bottom. What is that current? Is 2. So 2 over R1 plus R2. What's the final answer? Minus 5 over 5 plus 10 times 2, which is minus 10 over 15. So minus 10 over 15 is this IT2. So what is IT? IT is nothing but IT1 plus IT2. What is IT1? 1 amp. What is IT2? Minus 10 over 15, which is 5 over 15, which is 1 over 3 amp, right? It's not solved here, but we're solving it. Now, I know the IT here as a variable. Is it the correct calculation?
Yes.
How about VT? I'm gonna erase this. To get VT, what is VT? VT is VT1 plus VT2. Superposition, the solution of problem 1 plus the solution of problem 2. How to calculate it? Some people want to use VDR, voltage divider rule. Can we use VDR for problem 1? Yeah, let's use it. No need to use IT1 times 5. Let's use VDR. Get it? So VT1 equals using voltage divider rule, which is equal to 5 over 5 plus 10 times, what's the voltage source? 15. What's the final answer? 5 volts. How to find V2? Well, to find VT2, one solution is to find the current that goes here, but a smart student would use simple parallel combination for that circuit. So to calculate the V2, it's simply the 2 amp getting split across the parallel combination between 10 and 5, which is 4, right? What's the parallel combination between 10 and 5? I think it's 4. Well, it's 5 inverse plus 10 inverse, all inverse. 3.333? 3.33. What is that current? 2. It enters from the top. So VT2 equals 2 times 3.333, which is 6.666. 6.666. So VT equals VT1 plus VT2, which is 11.667 volts. Yeah, Shabab, the superposition, it's like splitting one problem into 2 problems. Solve for problem 1, solve for problem 2, combine numerically the answers, VT1 plus VT2. Now, again, we still have a problem with many students. Once they see this circuit, they say, oh, what is ITT1? Okay, then it's 15 over 10 plus 5. For that circuit, what is IT2? It's the current that goes through this resistor from bottom to top, and I told you to put plus and minus the polarity to avoid the passive sign configuration because you already wanted that current. If you redraw the circuit, IT2 is the current that goes from bottom to top. CDR is coming from top to bottom to two parallel resistors, so that's why we added the negative. If another student wanted to put plus and minus for the current IT2 that goes here, he has to put the negative sign from the passive sign configuration, not from because it's in the opposite direction. Get it?
هل يمكن نستعمل طريقة عشان نجيب الفولتج في الكرنت سورس؟
Well, to calculate the voltage in the current source, the only way to do it is KVL, or find the parallel combination and let the 2 amp goes through the resistor and V equal plus IR. And that's what we did here, the 6.66. It's 2 times R equivalent. Again, this problem, he was asking for the currents and the voltages, which is I total and V total. The slides show you only V total. It doesn't show you I total because I total is nothing but an exercise. So we did solve exercise 2.31. So in this exercise for the previous circuit, you have to find I total. And we did find it to be 0.333, right? Third. Now he also asked for what is I1, what is I2. We already calculated I2 in that circuit, which is IT2, which is IT. I'm sorry. Well, I1 and I2 are IT1 and IT2. So do you like my notation or the book notation? No, the book says it's IT. He splits it into I1 and I2. Do you like IT1 or IT2 or I1 and I2?
I1 and I2.
You like I1 and I2 better than IT1 and IT2? Which rotation? Okay, who thinks, that's okay, I'm not going to be offended. Who thinks if you make superposition IT to be I1 and I2 is better notation? Raise your hand.
IT1, T2?
Okay, who thinks IT1 and IT2 is a better notation? Raise your hand. Some people didn't even raise their hands. Well, why? So what you're saying is IT equals I1 plus I2.
Yes, because
T stands for total.
Yes.
Okay. Well, you can use it. Okay? Now, the problem with these is you can use I1 and I2. It's up to you. But in the exercise, in the way I solved it, it's IT1 plus IT2 equal to I total.
Can you explain
CDR.
the sign convention you think?
Okay.
The current.
Let me explain again. Chapter 1. No, that's chapter 2. That's the circuit, right? Okay. What did I call it? IT1 and IT2. So what did I say about I? Here you have 2 amp. Here you have 5. Here you have 10. What did I say?
What was it? You removed.
Yeah, that's the 2 amp. So you short circuit the voltage source, you keep the current source.
And the 15 ohm.
Oh, you're right, we have 15 ohm. You're right, we have 15 ohm. No, that's another problem. We didn't solve it yet. That's the original problem. You're right. So the 2 amp gets split into here and there, but we already defined IT2, which is I2 in the slide. You can say IT2. I call it IT2 to indicate that it's the same quantity IT that we're going to split. But the reason I picked this notation is what in the test he called it IX. It's going to be IX1 plus IX2. Get it? What if in the test it was already called I20 ohm? So you're going to call it I20 ohm 1, I20 ohm 2. You have two quantities.
Why don't we solve it the normal way? After that we say that IT is equal
Again, you have to be consistent. You can see I sub I hatum equals I hatum 1 plus I hatum 2. That's okay. Now, explaining the passive sign configuration. When you assign the direction of the current, you can put plus minus anywhere. But if you put it, you have to stick with it. So I decided to put it plus minus. So the 2 amp gets splitted here and there, right? Using CDR, it is 5 over, if I want to calculate that current, it's actually opposite of that. So I put a negative sign. يعني اللي حاطينه من فوق لتحت أنا في المعادلة هو أساسا السالب، حطيت سالب. لأن هذا السي دي ار بتعطيك اللي من فوق لتحت. بس أنا أبغى اللي من تحت لفوق فحطيت سالب. ما له دخل أني حطيت بلس ماينس هنا. لو حطيت بلس ماينس هنا تمام؟ وقلت الكرنت that goes from bottom to top. Again, I'm going to have another negative sign for the CDR, and I'm not going to have a negative sign for the passive sign configuration. Why? Because passive sign configuration applies only for Ohm's law and power. It's not applied for CDR. But it will make a mess. That's why I said keep the plus and minus here. And the negative sign is because we have two opposite direction currents over 5 plus 10 times 2. Get it? So the negative sign is because CDR gives you from top to bottom, the 2 goes from top to bottom, and the negative sign, I want this IT2, which is the one that goes through the 10 ohm resistor. Any question? Yeah.
Doctor, what I saw is that R1 you have shifted it into the, to make it parallel.
Yeah, that's okay, you can,
So
when you short circuit this,
the sign will be this.
it is the same.
Also.
It is the same. IT will be from plus minus like that.
This is what I saw.
Yeah. I'm not going to solve this example, but you can solve it by yourself. It's just we add a more resistor here, so what will happen here is for VDR, we have a parallel combination between 15 and 5 in series with 10. For IT2, you have to do node voltage. It's a bigger example. Also, I'm not going to do this checkpoint now. Maybe we'll do it next lecture because I have to explain Wheatstone bridge. Wheatstone bridge is a device, is a circuit, it's an application, okay? The only thing you need to know about Wheatstone bridge is it's in the field. The detector, if you have R1 and R2 proportional to R3 and Rx, the current will be 0. The moment I change R3, it's a variable resistor, the current will move. This helps me to measure the unknown resistance Rx. So you put the unknown resistance. This reminds you of what device in the lab? Ohm meter. So the ohm meter in the lab, the way it works, it has terminals, these two terminals, and you put your unknown resistance, and it does these things inside, and it calculates the current, and based on the calculations, you know the unknown resistance. It has adjustable resistance, R2 and R3. For the digital ohm meter, those are calculated numerically, but in the 50s or 40s, people had to do it manually to measure the resistance. Now, what is the important equation is, given the detector has 0 current, the equation of Rx is R2 over R1 times R3. So, in operation, the resistor R2 and R3 are adjusted in value until the detector indicates 0 current. Once the detector indicates 0 current, you can calculate the unknown resistance by this equation. You already know what is the value of R1 is fixed, R2 is variable, but you know how much you changed it, it's a knob. R3 is a variable, you also changed it. So if I bring you a question in the test, now we have a 0 detector current, and R2 and R3 were adjusted to be 5 ohm, and R1 was already fixed to be 10 ohm. What's Rx? 25 over 10. Easy. The derivation is not required, but you can read it if you are interested. And the way it works is at balance, if there is no current, if Ig is 0, the measured voltages here is going to be 0 because there is no current flowing. Now, it's not because current source has 0 voltage, it's because there is 0 current here. It means this acts like a short circuit. So there's no current here. So the voltage drop here across these two 0. Now, there is a huge derivation. You can say I1 plus I. The whole I1 will go to I3. Ig is 0. So if I1 is in series with I3, it means those two terminals are in parallel. Now the derivation starts as the following. At balance, what does balance mean? Ig is 0. KCL at node A, indicating I1 equals to I3. The whole I1 will go here. The voltage drop here across, it's not KB, the KCL indicates Ig is 0. The voltage drop here, we'll figure it out later. KCL at node B, the whole I2 will go to I4. KVL around the loop formed by R1, R2, and the detector, and it tells you at balance, A and B, the voltage drop here is 0 at balance. So if you do the equation, you will have R1, I1 equal R2 times I2. KVL around the loop formed the lower triangle. You will have this equation. If you divide those two equations, and you know I3 is equal to I1, I4 equals to I2, this implies that R3 over R1 equal Rx over R2, and this is the final equation. That's how to derive it. The key about Wheatstone bridge is at balance, Ig equal 0. And we already varied R2 and R3. We have a fixed R1. We want to calculate Rx, okay?
إذا كان العكس RX تكون مثلا عندنا value بRX تكون الRX اللي فيكس والR1 بتطلعها مثلا إذا كانت مو معلومة صح؟
Well, think of Rx is the way that you can connect it, but R1 it's inside the device. So if it's inside the device, the whole box here is inside the device, and R1 is inside. But yeah, you can, we call it Rx, X is to be in math as an unknown. Now that's what you need to know. So if in the test we can ask you what is the application of Wheatstone bridge? At balance, what does balance mean? It means the current that goes through the detector is 0. A given R1 and R2 and R. Maybe a trick question if I tell you what should be the value of R2 that gives us Rx. And we already know R3 and R1. That's another thing. Another ultra smart question, it tells you, find a combination of R2 and R3 such that Rx 5 ohm measured at 1. Then you have to find two numbers. If you multiply them, would equal to Rx and R1. But this is a design problem and it doesn't fit MCQ. Get it? So this is Wheatstone bridge. Any question about Wheatstone bridge? Yeah.
Alarm indicates variable
resistor. Rx is unknown resistor. The arrow on a resistor indicates variable, adjustable. You can adjust it.
Beside the second.
Yeah, it's knobs. You changed it. This one is This one is a current source, not a current source. This is an ohm meter, a current meter. A current meter that measures the current. If it's 0, it will be like that. There is current, it will be like. If Ig is 0, the whole current is 0, and the voltage drop at balance VA. Now, this is not a current source. This is a current meter. If there is no current flowing here, it means the potential difference here is 0. And this way you will have the equation R1 I1 equal R2 I2, the stop, and the other stop. So if you solve these two equations, that's the most important equation you have to know about Wheatstone bridge. So what Wheatstone bridge is used for? Measure unknown resistance. Get it? Okay. We have 5 minutes. Let's try to go back to this problem. Use superposition principle to find VT and IT for the circuit shown in figure 2.65. Now, how to solve this question is to write problem 1 and problem 2. Why 2 problems? Because we have two voltage sources this time. Now, if you draw the first circuit, you have to kill the right-hand side voltage source. So you will have something like 15. Yes, the 15. I'm putting it in parallel to make the circuit looks nice. In parallel with 5. Series with 10. Voltage source is 20. If I bring you the circuit in the major, can you solve it?
Yes.
Yeah. Many ways to solve it. You can use node voltage. You can use, so he wants VT1. I call this now VT1. Nakhli doesn't like it. So you can call it V1. Okay. So VT1 equals, the parallel combination between 15 and 5 is what?
3.75.
So this can be 3.75. So use VDR, 3.75 over 10 plus 3.75 times 20. Because I'm replacing this parallel with a single resistor. Yeah.
This is not current sources.
Yeah, that's a voltage source. So I replace it with a short circuit.
Okay.
If it was a current source, this will be open and this 15 will be hanging in the air. What did I tell you? If you have a resistance hanging in the air, voltage drop here is same as here.
Okay. So
The current is 0 because المسلك معلق في الهواء. But this time it's a short circuit. Now what's the final answer? VT1 or V1? 5.4 volts. Problem 2, how to draw the circuit? It's the other way around, right? $15. What is 5 parallel with 10? 3.3.
No, 20.
Whatever.
Or 10.
So VT2 is what? 3 point what? 3.33 over 15 plus 3.33 times 10. What's the final answer? 1.82 volts. So what is VT? Is VT1 plus VT2, my method, V1 plus V2, Nakhli's method, which is equal to 5.4 plus 1.82, which is equal to 6 or 7.1 volts.
المفروض 15
7.2, 7.1. I don't care. In the test, we will not give you 7.1, 7.2, 7.3. We'll give you either 7.1, 8. So you can do it real quickly to save 2 minutes in the test. Who asked the question?
المفروض بلس 15 ولا في
Well, this is
VT2
no, that's a 10 volt.
No, plus. Denominator.
That's a 15 ohm.
VT2 it should be
Plus 15.
3.50 over 15 plus 3.
Oh, you're right. 3. Oh, yeah, 15. If you want to leave, you can leave. Next time, hopefully, we will try to do the checkpoint. This checkpoint has too many problems, and maybe Wheatstone Bridge and start the new chapter. Okay? The major up until today's lecture. Maybe it will have some of the beginning of next lecture, but the material is chapter 1 and chapter 2. YouTube, watch YouTube يا شباب.
Doctor, VT2 should be this value, not 1.82.
0?
لا لا صح حسب كم
No, I'm correct. We got 7 points. There is no way we got 7. Double check. No. Yeah, what's your question?
Mesh analysis.
Huh?
Mesh.
Yeah.
We have, for example, like resistors.
No, I told you it's better to make it plus minus عشان كده.
الحين إذا حسبنا من هنا المش كارت من هنا نقول فولتج رايز
اللي هو IA minus IB في كلا الحالتين.
وكل الحالتين نعتبرها فولتج
هنا بيصير الفولتج رايز، هنا بيصير الفولتج دروب.
ونفس IA ماينس
IA minus IB فيكس ما يتغير.
بس
هذا أنا عرفت. في سؤال؟